Hi, today we're going to talk about using truth tables for arguments. Basically what we want to do, if there's a particular argument being made, we want to see if that argument is going to be valid. Let's take a look at the first example. If I play sports, I'm healthy. I play sports. This symbol here means therefore. So therefore I'm healthy. There is a way to, with some of them, to figure them out by just analyzing the statements, but that's not what we want to do. So what do we have here? We have P implies Q. If we call this P and this Q. So if I play sports, I'm healthy. I play sports. That means P. And our conclusion is going to be Q. It does make logical sense that this is true, but let's go through the proper procedure and determine that. So what do we have here? Here's what we're trying to do. We're going to determine about P implies Q. Then we're going to combine them together, because when you have these two statements here, they're considered to be together with AND. So then we're going to have P implies Q and P. And then finally what we're trying to prove is that if P implies Q and P, does that imply Q? Let's go ahead and complete that. True, false, true, true. These two together, so true, true is true. True, false, true and false is false. False and true is false, and false and true is false. So now we want this to imply Q. What do we have here? True, 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 false, false, true, false, true, true, false, false, true. If all the, basically what you want to get is you want to get tautology. If you're getting a tautology, this argument is going to be valid. Okay. At least one of them is F. Doesn't matter if it's only one. It's going to be an invalid argument. If you like movies, then we are friends. We are not friends. You don't like, therefore you don't like movies. So if you like movies, it's going to be P. We're friends. We're not friends. That will be not Q. This implies not P. So symbolically this can be written is P implies Q, not Q. And I'm going to show that this will imply that all these together will lead to conclusion that it's not P. So I already pre-filled this one out. So let's see, not Q, we have false, true, true. P implies Q is going to be true, false, true, true. So now we're doing P implies Q and not Q, so that's these two. It's going to be false, 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 true. Not P is going to be false, false, true, true. And finally we want this here to imply that. I'm going to see what's going on there. So it's true, false, false. False implies false, true, 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 true. Again, we got tautology. All of them are true. This argument is valid. If you eat fruit, then you're smart. You don't eat fruits, you're not smart. This here is P, implies Q. This here is not P, and this would imply not Q. symbolically, P implies Q, not P, therefore not Q. P implies Q, true, false, true, true. Not P will be false, false, true, true. P implies true and not P will be false, false, true, true. Not Q will be false, true, false, true. And we want this to imply that. So this one is true, this one is true, this one is false, and this one is true. So one of them right here is false, which means there is a situation in which all that is going to lead to a false conclusion. If you see any false in your final column, this argument will be invalid, which means you cannot say that it's going to be always correct. I'm great, or you're awesome, you're not awesome, therefore I'm not great. So this is P or Q. This is not Q, leading possibly to a conclusion that it's not P. So P or Q will be true, 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 false. Not Q will be false, true, false, true. P or Q and not Q. So P or Q and not Q will be false, true, false, false. Not P will be false, false, true, true. And this leading to that is going to be true, false, true, true. One false statement here. This argument is invalid. If I have a car, then I go to work. If I go to work, then I make money. So now we have three different statements involved. Therefore, if I have a car, then I make money. No? If I have a car, then I go to work. If I go to work, then I make money. So we're trying to conclude that P implies R. Sort of transitive property. One thing implies the other, and that thing in terms implies something else. Would the first statement imply the last statement? As you can see, this table is a little busier. You have to be very careful here. So P implies Q. We have true, true, false, false, true, 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 true. Q implies R. True, false, true, 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 false, true. Now one and the other, it's going to be true, false, 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 true, true, false, true. P implies R. So first and the third. True, false, true, false, true, 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 true. And now does this imply that? True, 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 true. Tautology, all of them are true. This is actually a valid argument. Next one. If I get paid, then I will not stay home. If I stay home, then I will read. If I read, I did not get paid. Very confusing argument. Let's see. So this will be P implies Q. But you have to be careful. If I get paid as P, I will not stay home as Q. This I stayed home, so this is not Q, implying R. And what we're trying to see, R implies I didn't get paid, not P. I already pre-filled the table just like I did before. This is somewhat of a big table. So we got P implies R, I'm sorry, P implies Q, not Q, then Q implying R, which is this one, these two together, not P, R implies not P, and then finally putting it all together. Let's see what happens here. P implies Q, true, true, false, false, true, 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 not Q. False, false, true, true, false, false, true, true. You have to go with not Q implying R. Be careful, you're going backwards, you're going from here to there, so watch out for the order. So false, true. Let's check. Not Q and R. False, true is true. False, false, false is true. True, true, true. True, false, true, false, 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 true, true, false, false, true, 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 false, false. So now we're doing this, this, and this. True, 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 and true, true. False. Any F's here will be true and true. That's also true. This one is true. This one is true, and this one is false. And this one's true. Okay. Not P. False, 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 false. T, 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 T. So R implying not P. You have to be very careful here. You're trying to do this implying that. Kind of have to ignore all that. So not, I'm sorry, T, R implying not P. This is false. This is true. This is false. This is false. No, I'm sorry, this is true. FF is true. TT, T, FT, T, TT, T, FT, T. So now we want to see if this here implies that. You already see the first one is false, then true, 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 true. So unfortunately, well, fortunately or unfortunately, this particular argument is going to be invalid because there's at least one F. And I believe this is our last example here. If you call in sick and I pick up your shift, then you don't get paid. You called in sick, therefore you did not get paid. So this here says that P and Q, call in sick is P, I pick up your shift is Q. You don't get paid, that's going to be R. So what we have here, this is P and Q, implies R. You called in sick, that's P. You didn't get paid, that is not R. No, I'm sorry, that's R because you don't get paid yet, it's R. So our whole thing is right here. So you called in sick and I pick up your shift, then you did not get paid, and you called in sick implies R. Let's go for it. So P and Q. True, true, false, 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 false. P and Q implies R. Careful with the direction. We're trying to go here, so from this to this. True, false, true, 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 and true. So the only time we get TF is when it's going to be false, right? So now this one here and P. Right, this one here and P. True, false, true, true, false, 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 and false. So now this implying R. Again, be careful with the direction. This here implying this here. That's true. That's true. That's true. That's TF. That's false. That's true. That's true. That's true. And that's true. Again, we have at least one F in here. That means this argument is invalid. So it is basically a pretty tedious process with making a truth table, but again, what you're trying to see is based on the argument that is provided. If you are going to get all of these T's, which means it's a tautology, then your argument is valid. If at least one of them is going to be false, then the argument is invalid. And that's pretty much how this works. I hope this helps.